You wake up, look at your phone, and it unlocks. You ask a voice assistant for the weather, and a streaming app suggests exactly what show to watch over breakfast. We use these tools every single day, usually grouping them all together under one broad category: artificial intelligence. It is confusing when the news uses the same word to describe a phone recognizing your face and a robot driving a car. Those are different tasks, and calling them both simply AI makes it difficult to understand the specific work being done. The technology behaves like a set of nesting dolls, a collection of specialized tools stacked one inside the other. Artificial intelligence is that largest outermost shell. It serves as the general concept of getting a machine to perform a task that usually requires human intelligence, like recognizing a voice or finding a pattern in a list. Understanding the general term is only the beginning. To see how the computer actually solves these problems, we have to look at the specific technologies hidden inside that outer shell. Inside that first shell is the engine driving our recommendation feeds and search results: machine learning. For decades, computers followed rigid rulebooks. If this happens, do that. Machine learning changed the goal. Today, we provide a computer with a vast library of data and allow it to figure out the rules on its own. This diagram shows how that works for your email. Messages flow in, pass through a sensor, and land in either your inbox or your spam folder. The system analyzes thousands of emails that people have already labeled as spam or safe. By looking at all those examples, it calculates which combinations of exclamation marks or links usually lead to the spam bin, creating its own sorting logic. In this system, programmers focus on curating high-quality examples, providing the raw material the machine needs to build its own logic. Standard machine learning hits a wall when information isn't organized into a neat spreadsheet. It struggles with messy formats like raw video, audio, or images. To handle those, we look at the next doll: deep learning. In this diagram, you can see the architecture that powers deep learning. It is a system called a neural network, designed to mirror the way interconnected neurons fire inside a human brain. When a photograph of a street enters this network, the system breaks the image into thousands of tiny fragments. The first column of nodes analyzes simple details, like a sharp edge or a patch of shadow. As those fragments pass through the deeper layers of the network, the system combines those tiny observations. Edges become a wheel, shadows become a bumper, and eventually the network identifies a car or a pedestrian. This breakthrough allowed computers to interpret the chaotic physical world with enough precision to navigate a city street. Now we reach the absolute center. The innermost doll is the newest layer: generative AI. While previous layers analyze and categorize existing data, this new layer takes those same pattern recognition skills and uses them to create things that have never existed before. By studying billions of examples of human writing and art, the system learns the structural rules of how we communicate. Once it knows those rules, it can predict which words or pixels should come next, assembling entirely original work on demand. This is the layer that powers the tools in the news today. When you type a prompt and a chatbot writes a custom essay, or a program renders a piece of digital artwork, you are interacting directly with generative AI. For most of history, computers served as high-speed calculators and categorizers. Today, they function as engines of original creation. If we look at this diagram, we can reassemble the whole stack to see the dependencies. Generative AI requires the power of deep learning. Deep learning is a specialized form of machine learning, and all of it lives under the broad definition of artificial intelligence. This stack represents advanced mathematics, executing pattern recognition at a scale that is hard for the human brain to visualize. The entire system relies on human data. Every calculation, prediction, and generated image is built out of the extensive library of human information we fed into it. The next time a new app goes viral or a headline warns about a new tech breakthrough, you can look closer at what it is actually doing. You can identify if the machine is sorting data, finding patterns, or generating something new. Pulling apart these layers reveals a logical, structured set of tools that are fundamentally changing how we interact with the world's information.